All right, diving in today, and we're looking at something pretty cool, actually, multi-object tracking.
Mhm.
In video analysis,
Oh, yeah.
you sent over some info on ByteTrack, and we go, whoa, we want to figure out why it's causing such a stir.
Right.
The big problem, obviously, is how to keep tabs on a bunch of different objects moving around in a video,
hmm
especially like when things get super crowded or an object, vanishes for a second.
Yeah, exactly. I mean, traditional methods really struggled, with keeping those IDs straight in those messy situations.
Right.
And the real breakthrough with ByteTrack was this idea of using information from those low confidence detections that normally just got tossed out.
Okay, okay.
And it led to some pretty impressive jumps in tracking accuracy. Like
Ah,
they were seeing improvements of like 10 to 15% on that really tough MOT17 benchmark, compared to a lot of the older algorithms.
okay, so it sounds like this whole approach to those initial detections, that's the real game changer. Like,
hmm
instead of just going with the super obvious ones, ByteTrack is looking at everything.
Yeah.
Can you kind of unpack that a little bit?
Sure, sure. So the really interesting thing here is that ByteTrack doesn't just immediately check out those detection boxes, right? The ones where the object detector is like, I'm not totally sure about this one.
Right.
Most of those older algorithms, they'd only focus on the slam dunks, the really clear cases.
Yeah, yeah. Okay, so how does ByteTrack actually use those less confident detections? Like, in practice, what's going on?
Well, they've got this clever two-stage association process.
Okay.
So first, it tries to match up the high confidence detections, the ones where it's pretty certain.
Right.
It matches those up to the tracks that it's already built. Think of it like a first pass, right?
Okay.
Just connecting the dots, the really obvious ones.
Yeah, that makes sense. Get all the easy ones out of the way.
hmm
So what about those leftover detections? The lower confidence ones. I feel like this is where it gets interesting.
Oh, absolutely. This is ByteTrack's secret sauce.
Okay.
It takes those lower confidence detections and tries to associate them with tracks from objects that might have, temporarily disappeared.
Okay.
Like, let's say someone walks behind a pillar or something.
Hmm.
You might get a low confidence detection as they're coming out the other side.
Right.
It's like a little blip on the radar.
Yeah, yeah.
And by actually paying attention to those, ByteTrack has a much better shot at picking up that track again, without missing a beat.
Wow. So even if something's partially hidden and the detector's not totally sure, ByteTrack is still trying to connect the dots. That's got to be a huge advantage, especially like you were saying in those really crowded scenes. Um, what were some of those limitations with those traditional approaches that ByteTrack was really trying to solve?
Yeah, well, one of the big ones was this problem of identity switches.
Oh,
The tracker might mistakenly assign a brand new ID to an object that had just reappeared.
Mhm.
And by hanging on to those low confidence detections, ByteTrack has more clues to work with.
right.
So it can keep the correct ID even when an object goes in and out of view.
So I guess ByteTrack needs something to actually find those objects in each frame, right? Like before it can start doing all this fancy tracking stuff.
Exactly. It relies on those state-of-the-art object detectors, like YOLA 5 or YOLO X.
Yeah, yeah.
These algorithms, they scan each frame and say, hey, I think there's an object here, and they give it a confidence score.
Right, right. So the detector spots them, and then ByteTrack steps in and
Yeah.
uses all that association magic, to connect those dice over time.
Exactly. And the result is, much more robust and accurate tracking of individual objects, keeping those IDs straight, even when they're partially hidden or moving erratically.
So to kind of sum up the big wins here, we've got those big performance gains on those standard benchmarks.
Yes.
Much more robust tracking in crowded scenes or when objects are hidden.
Right.
And it manages to do all that with a pretty elegant design, from what I understand.
Yeah, I think that's a pretty good summary. And that simplicity, I think that's part of what makes it so effective.
Where would you actually see this tech being used in real life?
Oh, all over the place. Think about self-driving cars, right? They need super reliable tracking of pedestrians, other cars, all that.
Yeah, that makes sense.
You've got advanced surveillance systems in those busy public areas,
Mhm.
robots that need to interact with people and follow them around.
Oh, wow.
Even in sports analytics, for really detailed player tracking.
So the big takeaway here, I think, is this idea of being more inclusive, with those initial detections. Not just focusing on the most obvious ones, but considering everything, even the less certain ones, to get that better overall tracking, especially in those tricky situations.
Mm-hmm.
It makes you wonder,
Yeah.
this whole principle of not immediately dismissing information that seems, I don't know, kind of shaky or unreliable.
Mm-hmm.
Could that apply in other areas? I mean, are we missing out on valuable insights by only focusing on the most, the highest confidence data, whether it's in other fields or even, just our everyday lives?
That's a really great question, and I'm going to leave that with you, our listener, to ponder. Keep those questions coming, and we'll see you in our next deep dive.
Until then.